think that's on. That's all. All right, on page 166, 23. And if you notice that, that's a phase shift, right? It's a phase shift, and what it's showing us and it's given, let's see, if I go pi here, 2 pi there, then this would be pi over 3 and 2 pi over 3. And if that thing has a peak right here, and then it shows it someplace like right in here, and then it goes down through there, and then at this point, this is 1, and this is a negative 1. And then down here, it's going down there, and then it's going back through here, and then kind of back here. So it's showing us something that looks like that. And it looks to me, this is what it looks to me like, that from here to here, this is the high point, this is half the period, and then the other half the period is back here. And I think that thing is a phase shift of pi over 6 back. See, this point right here would be a negative pi over 3. And that's what it looks like to me, that this would be a sine, and it's just going to be sine of x plus pi over 6. And the book says 23, it says 23 is cosine of x minus pi over 3. And it says it's a phase shift forward, and I guess it could be that. If you went minus pi over 3, that's possible. Y equals cosine of x minus pi over 3. And that would be possible. You move this thing forward to here. And that would be possible. So that's probably right. So sometimes what you can do is you can have the things be too, I think if you graphed either one of those in there, you would get essentially this graph. But it's not telling you which one it has to be. Because you have to look at it and say, what do you think this is? See, it says it's either c plus cosine x or y equals c plus sine x or cosine x minus d, or sine x minus d. All right. What I'm going to look at is ones that we can get pretty much an accurate description of it in terms of the kinds of things that I want to have you tell me. And notice in 26, the instruction says find the amplitude, the period, any vertical translation, and any phase shift of the graph of each function. So you have y 2/3 sine x minus pi over 2 plus. Okay, so the first thing is amplitude, and the amplitude is going to be what? Absolute value of 2/3. It's this value right out here. And then you could do period. And the period is going to be whatever this value is right here, divided into 2 pi. So this is going to be a 2 pi period. Now they're saying vertical translation and that's 0. That would be if you had a plus on the outside or plus over here or minus. So it's not moving it up or down at all. And then a phase shift. And what I would do for the phase shift, this is going to tell you right here what the phase shift is. And that's going to be left, right? Correct? Pi over 2. All right. When I do it, I'm going to ask this interval. And then what you do is you take, for the sine is always 0 is less than or equal to, and put whatever this is, x plus pi over 2, which is less than or equal to 2 pi. Because the normal interval for sine is 0 to 2 pi. And then take this and get x by itself in the middle. Well, you'd have to subtract pi over 2, right, to get x by itself. And the algebra of that says you subtract pi over 2 here and subtract pi over 2 here. So the result of the interval is going to be a negative pi over 2 less than or equal to x, which is less than or equal to, this is going to be 3 pi over 2. You know, to get a common denominator, you'd have to build the denominator with a 2, so you'd have to go 2 over 2, right? So you'd have 4 pi over 2 minus pi over 2 would be 3 pi over 2. And then the interval would be minus pi over 2. Now, if you were going to graph it, the easiest thing to do would be graph it over this interval as a normal sine curve. You'd divide this interval into 4 parts. Beginning, you'd have 5 positions. Beginning, 1/4 the way, 1/2 the way, 3/4, and end. And then you would, at the beginning, because it's sine, you would be what? On 0. And because there's no vertical shift, you'd be at 0. And then 1/4, you'd be at its maximum, which would be 2/3. And you'd be back at 0, 1/2. 3/4, you'd be at its minimum, minus 2/3. And then at the end, this interval, you would be back at 0. And you can see if you subtract, if you take the distance from here to here, that's 2 pi. So you verify the period. And you can see that this thing, the normal sine curve is shifted to the left. Right? So it's everything up here is verified by doing this interval. So you can do the interval first, do your amplitude, do your interval, you can come up with this, or you can do it manually, do the interval at the end and make sure you're right. Does that make sense? It's, you said this way. Does it make sense, James? Yeah.
Yeah. I guess and you said you could do it either way, right?
Well, I guess what I think, because what you want to do, these things here, you can calculate it out. I would suggest that you do your interval to verify that this follows, because it's just a way to make sure that what you've said is correct. The only thing that this interval isn't going to show you is check this part, but it's going to, the length here has got to be 2 pi long. The vertical translation, that's going to be something that this won't show you, because that's going to be plus or minus out in front. But then this phase shift, this should reflect that phase shift that you said happened. So this interval will verify your period and your phase shift. So if you look at it, say this is what I think, do your interval notation, then that should verify. And then if you really want to be accurate, you take the thing, put it in your calculator and see what it does, right? And then if this correlates with this, correlates with this, correlates with what the graphing calculator is showing you, then you know you're right. Because that's what you're doing a couple things. Trying to learn the trig, you're trying to be accurate for a test to get a good grade, right? And I'm just saying, a good grade comes by knowing how the correlation is between them. And then, if you wanted to really be sure, then you just go in here, go to y equals, and then what I would do is I would do this zoom and do this trig, so that you have that, it's laid out from minus 2 pi to plus 2 pi with, 0 to negative 4, 0 to plus 4 vertical. And then just go in here and put that in there. And I guess 2 divided by 3 times, and sine of x plus second. That's pi, isn't it? Over 2. I did some crazy thing that I shouldn't have done. I went to the next one. This one here, graph it. So now you look at that, and you can see that you're 2/3 high, right? Because that's 1. Because this window, when you do, see, this is 2 pi minus 2 pi. This is plus 2 pi on the horizontal. This is every pi over 2 is how far those horizontal spacings are apart. And then this is minus 4 to plus 4 vertical with hash marks at 1. So then when you look at this, you can say, well, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. And then this is 1, so it looks like it's 2/3 high, 2/3 low. And then I got my curve is this is a interval is from minus pi over 2 to 3 pi over 2, and it shows a sine curve in that interval, right? Because that's what I said the interval should show. It looks like a cosine curve, but it's a sine curve phase shifted to the left. So you can see that a sine curve and a sine curve phase shifted to the left, pi over 2 is the same, will have the same shape as a regular cosine curve. But the calculator should serve to verify what you're doing, and then you're trying to verify a lot of things. And if you know all of those things, then when you get out in the field and you're using it, then you have a good way of, you don't have the book, for reference to check your answers. You're just calculating what you know and verifying that the calculator does what your handwork does. That's the right way to use a calculator in a class. Don't rely on one thing to be the only source of your answer. All right, so I'll do 30. So y equals negative cosine pi x minus 1/3. Now the amplitude is going to be what? Absolute value of a minus 1. Now here's where using the absolute value is good. You know the amplitude is 1, but when you look at this, what do you know that cosine curve is going to be? Rotated around the x-axis. Correct? Because that's what happened, but it still has an amplitude of 1. And your period, it's going to be this value, because this value, when you run it through here, would be right there. So it's 2 pi over that value. So my period should be 2 according to what? Correct? Because it's always this b into 2 pi. I'll just do this right here is 2 pi over b. But this thing here, this will run right in there. So it'll be, b is here. Because your general form is this. A cosine bx minus d. And see, d is really what? Pi times 1/3, pi over 3. Correct? No, you take, see, this translates into minus cosine of pi x minus pi over 3. Dang it. So this is b, and you divide b into 2 pi. That's 2 pi over pi. That means the period's 2. And then, let's see, the next thing they were doing is a phase shift. Is that what the next thing was? Okay, vertical should be probably in first. But now notice that this is, see, when you run this pi through there, then the phase shift is going to be what? Right, pi over 3. And then vertical shift is 0. Now then we'll look at interval. And then on an interval, you want to take this whole value here and put it between, cosine's normal interval is 0 to 2 pi. But but now you put this pi x minus 1/3. So then what you do is you divide by pi, divide this by pi, this by pi. Now it's not coming out quite like, so it's 0 less than or equal to x minus 1/3. See, now you can see that my phase shift is not right according to what I thought, right? Because my phase shift is going to be right 1/3 rather than pi over 3. Yeah. So this is going to be, this has got to be 6/3 plus 1/3 is 7/3. So it's 1/3 less than or equal to x. Now these two conflict in what, what I was thinking was going to happen. Now, in order to verify it, what we're going to do is go into the calculator and see which one works. And I'm just going to clear that out. Clear this out. And I have to put this negative cosine and then go pi and then put a bracket x and this minus 1 divided by 3. Now this is saying that from a minus 1/3 over to 7/3, I should have that interval. So what I want to do is go in here and go to standard 6 and look at it in that respect. And then maybe make my window to verify what's going on is run this from, rather than a minus 10, run it from a minus 2 out to plus 2. What did I do? Make this 1/3. 1 divided by 2, 3. And then because I'm going height is 1, make that minimum like minus 2 and the maximum 2. And then graph it. Now you can see that isn't even coming out the way I would think, because this is supposed to be 1/3, right? I should start back here and go out to 7/3. So 1. Didn't I make that thing 1/3 window? I made that scalar 1/3. 2 long 1/3. 1/3 to 7/3. Okay, what did I do wrong? Well, now it's coming out a little different. Looks a little different. Here's 1, 2, 3, 4, 5. That's 6. That, this isn't working right. What was you going to say? What is this? This is 30. What if we're supposed to get? 1 is, we got that. Then it says 2 is the period, that we got. And it's 1/3 to the right. That's what this is indicating right here. So this is correct. Why isn't it? This is correct. And this right here is right. Why is my interval? Okay.
Because the phase shift instead of 7 was 1/3, you have pi over 3, you distribute the pi in. Granted, it's a rule that you can distribute it, figure it out, turn it off.
I mean, this is the correct thing here, right? To add those. Well, let's see. Maybe I'm thinking about this thing wrong. Goes from a minus 1/3, and the cosine should be, and it's rotated. Is my window set up? I have to think about this.
Choose your x max.
Oh, this is a negative.
Yeah,
That's minimum, but this.
Max is 3 because 7 and 1/3 is 2 and 1/3.
Oh yeah, okay.
So change it to like 3. So
Yeah, I was thinking vertical. So go 3.
maybe that's why.
Maybe.
You can't see the whole shift.
But it should at this plus, oh, it's plus 1/3. Okay. I don't know why I was going at plus 1/3. Okay, we're good. At plus 1/3, it's rather than a maximum, it's minimum, right? We gotta make that window bigger. We'll run that thing out to 4. See, here's 1/3. It's at its minimum, right? Then it goes through here, goes to its maximum, and then it should come right back down to its minimum, right? And its minimum is right there. And that's how many over? Yeah. I don't know why I was thinking it was a minus 1/3. That looked right there. But see, at a plus 1/3, it's at its minimum, and that's that inverted, right? Goes through, goes to its maximum, comes through, goes to its minimum, and that's at plus 7/3. Whew. Well, it's harder than it ought to have been. So everything agrees. Did you follow when I was struggling, what I was doing? I wasn't seeing what I wanted to see, and I wasn't putting things in right. So then we can see that this is wrong on a phase shift. The phase shift is actually 1/3, and it's to the right. And from here to here, it's too long. Well, let's see if we can do something else. Maybe I can be more successful on 32. Minus 1 plus 1/2 cosine 2x minus 3 pi. Okay, we do amplitude. So the amplitude is going to be absolute value of one half, right? See, that's this thing right here. This is the form we have. C plus A cosine bx minus d. And the 1/2 is in the amplitude position. And then we do period. And the period's going to be this, right? This thing, because the period is 2 pi over b, then this is 2 pi over 2, which is pi. And then what's the next thing? Did I do a vertical shift? Saying we're going down 1, right? So it's down 1. And then phase shift. And that should be 3 pi right. Now we'll look at the interval to try to verify. So we're going to go 0 less than or equal to, and we'll put all this inside there. 2x minus 3 pi. 2 pi. Now, what we want to do is add 3 pi. So that gives us 3 pi less than or equal to 2x less than or equal to 5 pi. Then we have to divide by 2. And so this is our interval. We're going to graph at 3 pi over 2 less than or equal to x, which is less than or equal to 5 pi over 2. Now if we subtract the 3 pi over 2 from 5 pi over 2, how long is it? Okay, it's 2 pi over 2. So if we go 5 pi over 2, and we subtract 3 pi over 2, and that's 5 pi minus 3 pi over 2, which is 2 pi over 2, which is pi. So this is right. That's correct. This is right. And phase shift. This thing is phase shifted to the right, 3 pi over 2, right? 3 pi over 2. Maybe we should go back and re-look at phase shift. What is it telling us phase shift is? Function, plot the points. I'm just really sure that this is right, because that's the interval, and that says the phase shift is 3 pi over 2. So the way I'm figuring this phase shift, it isn't just this, it's this over this. That's what it is. D is called the argument. And all right, if you look back on page 158, it's saying method 1 for doing the phase shift. You see what they're doing is they're putting that 0 is less than or equal to x minus pi over 3 less than or equal to 2 pi. They're doing this method right here. And then they're showing you that the phase shift is pi over 3. And they say method 2 they're not showing you when you have, okay, example 3. There's what, this is what they're saying. You see example 3, method 2. They're saying that what you have to do is take this thing and you got to convert it into factoring the 2 out. And then use this to figure your period, and this is your phase shift. So it has to be, technically, this is wrong the way it is written. And that might be just me writing it. Because normally I don't do this kind of phase shift. But this is going to be x minus d. So you want to run it that way, so that the b is outside, and then this d, this isn't d, this is d. So this last one, let's take a look at that. Notice the pi was out, so this is the phase shift. Because that's what it says, method 2. That's how you, I always have used method 1, so I should have looked at it a little closer. But this is actually set up for method 2. This is the B and that's the D. So this one, but this 2 is included in here, you've got to factor that out so that it's just an X. And then this becomes the phase shift. And we can see that when I did it did it incorrectly and got 3 pi, this will give you the correct one. So it's 3 pi over 2. That's why I like to do interval, because unfortunately for you, you have to go through me kind of searching a little bit. I never do it. I never do it this way. So I kind of forgot that you had to factor that out. Do you understand? from my mistake, what you got to do. What? Yeah. Are you, Lucas, are you good with it? Okay. So if you're doing it both ways, you know, then what you can see is, and then what I would do is I'd take the thing and I'd put that thing in the calculator. I'd put this thing in, and I'll go ahead and put it in. You know, clear this one out, and then be sure that when that you understand that minus sign is the first when it's the first one in the equation. You have to use. You can't use. It'll give you a syntax error, and you know how to go figure out where your syntax error is, right? I'll put the wrong minus sign in. I'll just show you. It'll be easy to correct. If I put this minus sign in, 1, and then go plus 1 divided by 2 cosine. And now it's not going to make any difference. I can put it in just exactly the way this is. 2x, I don't have to factor that out, minus 3 pi. Now, if I try to graph this, it'll go syntax error. And this is what you want to do is don't quit, go to. And then it's going to take me right to where the error is. And then you can say, oh, I see what it is. It's the wrong sign. And then you go ahead and graph it. Now, if I had used the wrong sign in both places, it'd fire me up with a syntax error again. Now, being this is in pi generation, if you want to verify this a little closer, you could go in and take a look at it in the trig. Go down here to 7, see what it looks like there. Now you can see that it looks like this minus 1 right here is where it's going down, going through. So that's a vertical shift down. It appears to be going up and down 1/2, right? From here it goes up 1/2, and from here it goes down 1/2. Now it's saying that 3 pi over 2 is the beginning of my interval. Well, this is pi over 2. This is pi. So it's an inverted. No, it's a regular cosine. So it's starting at its maximum right there. And that supposedly should be pi over 3. Now another way you can look at this if you want to check it is you can go trace and then go along that thing. But now it won't give you 3 pi over 2, but it's going to give you so you want to find about where you are maximum there, and it's 1.57. And the question is that, and it's saying the beginning of my interval is 3 pi over 2. So that's pi over 2, so the beginning is 3 pi over 2, right? So it's out here. And it's at 0.5, and that's 3 pi over 2. So it looks good to me. All right. I'm going pretty slow on these things.
That's good though. It makes more sense after we do it.
Yeah.
Especially at the beginning.
I think what we should do next time, we should come back. You can look at these, but for sure we should look and try to do some of those 53 through 56. Notice that they're doing vertical shifts, they're doing phase shifts, and you know they're everything is included, so we should look at some of those so we get an idea of what to do. So,
And,